Continuing on with section 4.3, rational inequalities and applications. Well, let's go to page 2. Page 2, there it is. Okay, so on this page we are solving rational inequalities, a little bit different procedure than solving equations. So first thing I'd see is that I have a rational expression, x divided by x squared minus 4. Here's what I'm thinking. Let's set up a sign chart, because sign charts are good tools to help us compare things to zero, and that's what we have here. So let's set up a sign chart. Alright, so in order to set up a sign chart, we're going to have to analyze this function a little bit. I'm going to say let f of x equal the left-hand side of this inequality, which is x over x squared minus 4, which I can rewrite as x over x plus 2 times x minus 2. That's the factoring out the perfect difference of two squares there. So my numerator here, I know that f of x will equal 0 at x equals 0, and I know that f of x is undefined at x equals plus or minus 2. Okay, so let's go ahead and take a look at a sign chart here. I'm going to start by just getting a line to start off with there, and then we're going to say that this is a number line that continues infinitely in both directions. We're going to analyze f of x on the top and x on the bottom. We need to put our important points. We have a 0 at x equals 0. At x equals positive 2, we have a domain restriction. At x equals negative 2, we also have a domain restriction. So there's our sign chart. Now let's go ahead and think of what happens. So we basically have three factors here, x plus 2, and x minus 2. And to the right of x equals 2, all of these factors are positive. So my sign chart is positive in that region. Once I cross over x equals 2, this factor right here turns negative. So I'm going to have a positive divided by the product of a positive and a negative. So that's going to be negative. Alright, so what happens as I cross over from 0 to the negative side of the number line? Well, this x is going to turn negative, so then I'm going to have a negative divided by the product of a positive and negative. So those two negatives are going to cancel out. My sign chart will be positive in this region. Last but not least, once I cross over to the left of negative 2, x plus 2 becomes negative. So now I have three negatives. That results in a negative result. So there's my sign chart for this problem. So let's go back and answer the question now. We want to know when f of x is greater than 0. So I'm going to say f of x is greater than 0 on the interval from negative 2 to 0. And I have to union that with the interval from 2 to infinity. Alright, so that was pretty easy. Let's move on to the next example. Certainly it's going to be a little trickier. Holy cow, look at this next example. This thing looks crazy. In fact, this is a whole lot trickier. But hopefully we'll recognize fairly quickly that we've already done a lot of work on the functions involved in this inequality. So the first thing I notice is on my right hand side I have 1/2 times x minus 1. And we've already looked at that and said that's the same as x over x minus 2. Whoa, hold on, folks. That's the same as x minus 2 over 2. You deserve better than this awful 2 right there, so let's fix that. Again, x minus 2 over 2. Okay, so let's rewrite this inequality. It's going to be on the left-hand side, x cubed minus 2x plus 1 all over x minus 1. And then on the right-hand side, it's going to be x minus 2 over 2. All right, so one of the things that you're tempted to do, right now I know you want to multiply both sides of this thing by x minus 1. But you don't know if x minus 1 is positive or negative. Okay, we'd have to consider two different cases, because if x minus 1 is positive, this inequality will still point to the left. If x minus 1 is negative, then we would have to flip this inequality so that it opened to the right. I don't want to do that. I want to try and avoid, if at all possible, having to multiply or divide by something that I don't know if it's negative or positive. So what I'm going to do is I'm going to multiply both sides of the left-hand side by 2 over 2, and both sides on the right by x minus 1 over x minus 1. So what's my goal here? My goal here is to get a common denominator on both sides of the inequality. And you might say, well, wait, you said I couldn't multiply by x minus 1 because I didn't know if it was positive or negative. But when I multiply by x minus 1 over x minus 1, it is equivalent to 1. It's not a negative, so I don't have to worry about changing any signs in the inequality. Okay, so once we do that multiplication, we get the following. We get 2x cubed minus 4x plus 2 all over the quantity 2 times x minus 1. And we want to see when that's greater than or equal to, I'm going to have x squared minus 3x plus 2 all over 2 times quantity x minus 1. Oh, hey, jumping around. Okay, so what now? Well, anytime I want to solve an inequality, I'd like to get a 0 on one side because life is easier with 0 on one side of an inequality. So I'm going to subtract this thing on the right from both sides of the inequality, and that's going to give me the following. And we have 2x cubed minus 4x plus 2 over 2 times quantity x minus 1 minus x squared minus 3x plus 2 over 2 times quantity x minus 1. And we want to know when that's greater than or equal to 0 because we subtracted this from both sides. Because I have the same denominator on the left, I can simplify things a little bit. So this will become 2x cubed. Let's see, it's going to be minus x squared. And then I have negative 4x minus negative 3x. That's negative 4x plus 3x, so that's going to be minus an x. And then I have 2 minus 2, which is 0. So that is my numerator on the left, and we're going to divide that by 2 times quantity x minus 1. Again, we want to know when that's greater than or equal to 0. All right, so if you recall from the problem, the second problem on the first side, we were able to factor 2x cubed minus x squared minus x into x times the quantity 2x plus 1 times the quantity x minus 1. And then our denominator is still 2 times the quantity x minus 1. So we want to know when that's greater than or equal to 0. I don't know about you, but this looks like a perfect application for a sign chart. So let's go ahead and let's draw a number line. Okay, we're going to go ahead and show that it goes infinitely in both directions. And on the top, I'm going to call this thing on the left my function f of x. And we want to know when that thing is 0 or when it's undefined. Well, we have zeros at x equals 0. And then we have a 0 at negative 1/2. And then x equals 1, it's not a 0. It's a restricted value from the domain. So I'm going to mark it as that. I know it would make the numerator 0, but because it's also in the denominator, it's a restricted value. All right, so let's go ahead and now that we have our zeros and our domain restrictions marked on this sign chart, let's go ahead and see what happens to the sign of this rational expression. If I'm to the right of x equals 1, all of these factors are positive. So my sign chart is going to be positive in that region. When we cross over x equals 1 and we go just to the left of x equals 1, this factor right here and this factor right here turn negative. But those two factors cancel each other out. Remember, I could show those as canceled out like that. But when I cross over x equals 1, those two factors turn negative. But the net result is still a positive value because a negative divided by a negative is a positive. Okay, let's continue down the number line and go across x equals 0. So that factor right there will turn negative. I now have 3 negative values. That means I'm going to have a negative output for this function. And then last but not least, I cross over negative 1/2, and this factor turns negative. Now I have an even number of negatives. There are 4 of them, so that result will be positive. Notice that the 2 down here is always positive, so I didn't even mention it. All right, we're ready to state our final answer. So the solution to this thing, the solution is when, so we want greater than or equal to 0, which means I need to include my zeros. The solution is from negative infinity to negative 1/2 with a square bracket. And then I'm going to union that with 0 to 1. I have to take 1 out because that is a domain restriction, and then continue from 1 on up to infinity. There's my final answer, folks. Let's just take a peek back at what we've done here. There's all the work for page 2. That was pretty quick. I hope you've enjoyed this little trip down solving rational inequalities lane. Hope you enjoyed this and are successful at WebAssign.